We're starting off Unit 2, which is our polynomial unit, with a look at complex numbers. Our essential question is looking at how we perform operations with complex numbers. First of all, as you know, you can't take the square root of a negative number and get a real value. So what we do is factor out the negative. The square root of 16 is 4, and the square root of negative 1 is I, or the imaginary number. For 2b, 18 is not a perfect square, so we will simplify the radical. 9 is a perfect square factor of 18. Then we have the negative 1, and the 2 is left over. So when we take the square root of 9 and get 3, we'll multiply that by the 2. Square root of negative 1 is I, and 2 is left under the radical. When you're organizing your answer, put the coefficient first. Treat the I kind of like a variable, and if you have a radical left over, that would go at the end. We're going to take a quick look at the powers of I so that we can see the cycle that occurs as the powers increase. First of all, anything to the 0 power is 1, including the imaginary number. I to the first power would just be I. I squared would be the square root of negative 1 squared, which is negative 1. I cubed is I squared times I. I squared is negative 1, so I cubed is negative I. I to the fourth is I squared times I squared, which is negative 1 times negative 1, or positive 1. I to the fifth would be I times I to the fourth, but I to the fourth is 1, so I to the fifth is I. I to the sixth would be I squared times I to the fourth. I to the fourth is 1, and I squared is negative 1. The pattern continues. I to the seventh would be the same as I cubed, which is negative I. I to the eighth would be the same as I to the fourth, which is positive 1. So to simplify powers of I, you find out if it's a multiple of 4, it would be equal to 1. If the remainder when you divide by 4 is 1, such as this one, 5 divided by 4 has a remainder of 1, it will be equal to I. If it has a remainder of 2, it would be equal to I squared. If dividing by 4 it has a remainder of 3, it would be equal to I cubed, and so on. So to simplify these powers of I, we simply find out what the remainder is after we divide by 4. 4 goes into 44 evenly, so the remainder is 2, and I squared is negative 1. 4 goes into 120 evenly, so the remainder is 3, and I cubed is negative I. Complex numbers can have a real part as well as an imaginary part. So when you see A, that is the real part. B times I, B would be the coefficient of the imaginary part. So we simply set the real part equal to A, and the imaginary part equal to BI. Dividing both sides by I, we would get B equals 6. For part B, notice that we have two pieces to our real part. We have the A and the positive 6. So we will set that whole piece equal to the real part on the other side. Subtracting 6 from both sides, we get A equals 0. Setting the imaginary piece equal to negative 5I. Dividing both sides by I, we get 2b equals negative 5. So to solve for b, we'll divide both sides by 2. Standard form for imaginary numbers is, as we just saw, a plus bi. So the real part goes first, and the imaginary part is second. In this case, we have the real part of 2. We just need to simplify that square root of 9. The square root of 9 is 3, and the square root of negative 1 is I. Part B, simplifying I squared, which is negative 1. That ends up being our real part. So I'm going to flip this around so it's in the right order. 3 times negative 1 is negative 3, minus the imaginary part of 6i. Part C, distributing our negative 4. Make sure you multiply that by both pieces. And then combining our like terms, we get -1 plus 22i. Part D, we need to FOIL. So we have 4 times 2, 4 times -3i, 5i times 2, and 5i times -3i would give us a -15i squared. Combining those like terms in the middle, and simplifying this piece on the end because I squared is -1, we end up with another real piece of positive 15, adding that to the 8, we get 23 minus 2i. This time we have conjugates. The shortcut to multiplying conjugates is you multiply your first term and you multiply your last terms together. Those middle two terms, real quickly, in case you don't remember, we would get a positive 8i canceling with that negative 8i. The 64 would be multiplied by -1 for that I squared, which would end up being 1 plus 64, or 65. For this example, similar to rationalizing a denominator with a radical, in order to put this in standard form, we need to multiply by the conjugate of the denominator. Foiling in the numerator, we have 3 times 3, 3 times 4i, 2i times 3, and 2i times 4i. In the denominator with those conjugates, we can just multiply the first terms, which would be 3 times 3, and the -4i times positive 4i. Simplifying in the numerator, combining those like terms, simplifying that I squared to -1. In the denominator, simplifying our I squared to -1. And combining our like terms. In the numerator, we have a -8 plus the 9 plus 18i. In the denominator, that becomes a positive 16 when we multiply it by the -1. 9 plus 16 gives us 25. For the final step, putting this in standard form, we distribute that 25 to both pieces in the numerator. Remember, standard form is your real piece plus your imaginary piece, so we need to separate them out to get this into standard form. Our last example, we're going to find the zeros of a quadratic equation. There are 3 different ways to do that. We can try and factor. This would be the AC method, what multiplies to 6 and adds to -1. In order to multiply to a positive, both values would have to be the same sign, so we would have to have 2 positives or 2 negatives. There are not 2 negative numbers that multiply to a positive 6 and add to -1, so this one does not factor. The second option is completing the square. Since that is not the most fun way to solve a quadratic, we will use the quadratic formula instead. X equals opposite of b plus or minus the square root, b squared minus 4ac all over 2a. Remember, a is the coefficient of x squared, b is the coefficient of x, and c is our constant. Subbing in those values, the opposite of b is 1, plus or minus the square root of 1 squared minus 4 times 2 times 3 all over 2 times 2. Simplifying under the radical, we have 1 minus 24 all over 4. 1 minus 24 is -23. So to simplify this, we'll pull the I out from under the radical, giving us I times the square root of 23, which does not simplify any further.